Hi everyone, I hope you had a wonderful day. We're going to start section 5. We're only going to do the first part of it in this video. And the objective is to prove that two lines are parallel. So you're going to need your packet for the majority of this lesson. So we're going to write down some postulates, and they're going to be converse of previous postulates that we have learned. So for example, the converse of corresponding angles postulate. Before we learned about the corresponding angles postulate, which was saying that if two lines are parallel, then corresponding angles are congruent. Well, remember the converse means we switch the if and the then. And the then. So this is saying that if two lines are cut by a transversal, so that corresponding angles are congruent, then the lines are parallel. All right, and don't mind the camel. I had a student tell me I needed to add some animals to my lessons, so that is exactly what I did. So I want you to pause the video and write this down. It's 3.4, converse of corresponding angles postulate. Okay, so this is just the reverse of what we had before. So now this is saying that if angle 1 and angle 3 are congruent, then we can say that AB is parallel to one another. And remember, this is the parallel symbol here. Okay, we have some more converses to write down. And not talking about the shoes, obviously. So we have the alternate exterior angles converse, the consecutive interior angles converse. Now some of you might call that same side. That's fine. Alternate interior angles converse and perpendicular transversal converse. So take a moment to pause the video, write all these down. I believe they're on the 4th and 5th pages of your packet. And make sure you write these down. So again, using these theorems, we can say that if we have two alternate exterior angles that are congruent, then we can say the two lines are parallel. Same thing with if the two consecutive interior angles add up to 180, then we can say the two lines are parallel. If we know the interior angles, alternate interior angles are congruent, then we can say the two lines are parallel. And if two lines are perpendicular to the same line, then they are parallel. Make sure you guys write down these, I just noticed this, write down these examples here, okay? Just so you have an example of what that conjecture looks like, that converse statement. And this is the last one you'll have to write down, the parallel postulate. If given a line and a point not on a line, then there exists exactly one line through that point that is parallel to that given line. So pause the video and write this one down. All right, we're going to move along to some examples. So given angle 1 and angle 6 are congruent to each other, determine which lines are parallel and explain your reasoning using your new postulates or theorems. So here is angle 1 and here is angle 6. And we know that they are congruent to one another. So what two lines are going to be parallel then? It's going to be L and N are going to be parallel to one another. L is parallel to N. And why is that? Why can we say that? What's our reasoning behind that? What theorem? Look through your packet, and it is the alternate oops, if my iPad will work here. I swear my MemeoPad is coming soon. I hope. I hope. Alternate exterior angles converse. That's going to be your key word, converse. So make sure you write that down, the converse part for sure. All right, so we can say that L and N are parallel to one another. Okay, the next one, copy and complete the proof. This is of theorem 3.5 in your packet. Go ahead and pause the video. All right, so we know angle 1 and angle 2 are congruent to each other because that's given. How can we say that angle 2 is congruent to angle 3? It is because of the definition of vertical angles. So the definition of vertical angles, which is my favorite angle, if you didn't know that. Okay. Then we can say angle 1 is congruent to angle 3 because of the transitive property. So our last line has to be L is parallel to M. And why is that? Why can we say that? Because of the converse of corresponding angles. And make sure you write all of that out, of corresponding angles. All right. So we've just been doing what we have been doing, but now it's backwards. It's flipped. We're using converses. So for tomorrow, if you would like, we're going to go over this proof together, but on page 212, number 25. You guys can try it. We're going to go over it again tomorrow as a group. And again, let me know if you have any questions, concerns, comments. Comment on the blog, email me, or write them down. We can talk about them at the beginning of class. All right, you guys have a great night, and we'll see you tomorrow.